All right, so we're referring to this function here. The nice thing is it's already in factored form. I've got 1/2 times x minus 2 times x plus 1 times x minus 5. These ones here have some multiplicities. But first they want the leading coefficient and the degree. So that would be like if I multiplied this out, which I don't need to, but if I did, I would just multiply the biggest part of each part to get that first leading term. So that would be like a 1/2 times an x to the third times an x squared. And that would all work out to be 1/2 x to the sixth. And that'll help me answer these degrees. The leading coefficient is positive, so I know the graph is going to end pointing upward. The degree is 6, which is even, so I know they're going to match. So I know on both sides it's going to do that. So the end behavior is going to be up and up, so that'll be y going to positive infinity and positive infinity. The zeros and their multiplicity organized in a table. Okay. So it looks like we have 3 zeros. So the first 0 is going to be 2, 0, because when I plug 2 in for this, I get 0. It has a multiplicity of 1. And so therefore it's going to cross the x-axis because there will be a sign change in the y. The second 0, we plug in a -1 here to get 0. So that's going to be -1, 0. Its multiplicity is 3 because that's the power there. So we have a multiplicity of 3. So therefore it will cross the x-axis because it is odd. There will be a sign change there, but when it crosses, it will do a little mini cubic because now we're going to have to graph these. So the degree 1 or multiplicity of 1 will just do like a mini line. It'll just cross right through. That's what I like to think of. And then the last 0 is 5, 0. So we got 5, 0. That has a multiplicity of 2. So there will not be a sign change at that 0. Therefore, it will bounce off the x-axis. And since it's a degree 2, it will look like a little mini parabola or a little mini x squared there. All right, so for y-intercept, we're plugging in 0 for x, solving for y. And the function was 1/2 0 minus 2 times 0 plus 1 to the third, I think that was, yep. And then 0 minus 5 squared. So I do that out, I get 1/2 times -2 times 1 to the third times -5 squared. So that'll be y equals, I'll multiply these together and get -1. And then times 1 is still just -1, and then -5 squared is 25, and we're getting y equals -25. So our y-intercept is -25. All right, we're going to use all this information to sketch a graph. So on the x-axis, we can go up by ones. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -5, 5. On the y-axis, we're going to go down 25. So we'll go by 5s. So we'll say -10, -20. So 0, -25 is right there. I'm going to graph those intercepts. So at 2, 0, I got a dot there. At -1, 0, I got a dot there. And at 5, 0, I got a x-intercept there. All right, we know the end behavior was up and up. So I know the end behavior here is up. We know here is up. At the 0, -1, it's going to cross and be a mini cubic. So it's going to do this because it's coming from the top, and we're going to make a little x cubed here. Okay, then it's going to come down. So it's coming down from here. It's going to do the little mini cubic because that degree is 3. Then it's going to go down, pass through the y-intercept, come back. And at the 0, 2, it's going to cross like a mini line. So it's just going to go straight through. So we're just going to go straight through on our way up. Then it's going to come up here. It's going to turn around, come back down to this x-intercept. And since the degree is 2, it's going to bounce, and it's going to be like a little mini x squared. So I know it's going to come down here and bounce like a little mini parabola, and then go up to the end behavior. So comes down, does the little cubic, goes down here, comes up, goes through like a line, turns around, comes down, does like a little mini parabola, and finishes up. So that's how you graph one of those.